Hi everyone, welcome to Integral Calculus. Today we explore lesson 5.5, integration by u-substitution for definite integrals. Let's take a look at a few examples. A. Integral from 0 to 3, 1 over 5x plus 1 dx. If we let u equal 5x plus 1, then we have the integral of 1 over u, which we know how to find the antiderivative of. So that is a good substitution. U equal to 5x plus 1. du is 5 dx. So dx is 1 over 5 du. Do the substitution. And we have the integral of 1 over u times 1 over 5 du. Well, the function is in terms of u now, which means that we have to also change the limit of the integral. From the u equal 5x plus 1, we can get the new upper limit to be 5 times 3 plus 1, which is 16. The new lower limit to be 5 times 0 plus 1, which is 1. Limit from 1 to 16. Okay. Now, the antiderivative of 1 over u is ln absolute value of u. Evaluate this from 1 to 16. And we have 1 over 5 ln of 16 minus, well, when we sub in 1, ln 1 is 0. And that is it. 1 over 5 ln 16. Pretty slick. Let's do another example. B. Integral square root e to e ln x over x dx. For this problem, notice that derivative of ln x is 1 over x. So it is good to let ln x be u. U is ln x. Du is 1 over x dx. And I'm gonna rewrite this as root e to e ln x times 1 over x dx, so you can see the substitution more clear. Same thing here. We have to update the limit. Upper limit is ln e 1. Lower limit ln square root e 1 over 2. So use the u sub, and we would have integral from 1 to 2 to 1. U times du. Oh, we have a u 2 over 2. Evaluate from 1 over 2 to 1. So I'm going to pull out the 1 over 2 here. Make my life a little easy with the calculation. 1 square is 1. 1 over 2 square is 1/4. Okay. So we have a half multiplied to 3/4, which is 3 over 8. We can sketch out the graph of ln x over x. Best to use decimals. X, y. And the graph look like this. from root E to E. It's right here. Root E to E. You have this area. This area is the same as the area of the function f of u equals u. So what? U, and here come f of u. So, well, f of u is just u. Just a straight line here. This f u equals u. 1 over 2 to 1. What is so cool about these two areas that same area? And that is the cool thing about the u-substitution. We change the variable. The area stay the same. The function is different though. The area stay the same. I'm gonna write this as fx equal to ln(x) over x. Okay, let's do another example. C. Integral 0 to 1 ex over 1 plus e to the 2x dx. That is 0 to 1. And we can write e to the 2x as ex square. So that means I can rewrite this as 1 over 1 plus e to the x square times ex dx. Notice that the derivative of ex is ex. So it is good to let u to be e to the x. Du is ex dx. Ah, we have a substitution right there. We just have to change the limit. Upper limit is e to the power 1, which is e. Lower limit is e to the power 0, 1. Now we can do the u-sub to get integral 1 to e 1 over 1 plus u square times du. Oh, what is the antiderivative of this? Arctan. So it's arctangent of u. Evaluate from 1 to e. So we have arctan of e minus arctan. Now this is another notation for arctangent of 1. Well, arctangent of 1 is pi 4. So the answer is arctan of e minus pi over 4. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. See you in the next video.